Okay, question C. The air also contained oxygen, nitrogen and carbon dioxide. Gives us information about boiling and freezing temperatures. The scientists continue to cool the air to a temperature of minus 190 degrees Celsius. What is the state of each substance at minus 190 degrees Celsius? And tick one box for each row of the table. Okay, these questions, often students don't like them a great deal. I'm going to show you how I'd approach this. So I'm going to look at oxygen first of all. I'm going to imagine a sort of a line there, and I'm going to put down the two values it's got. So I've got freezing is, so that's minus 218. These are known as its fixed points, and over here I've got minus 183. I know everything to this side of this is solid. I know here I've got liquid, and here I've got gas. Okay, and then I'm going to find out 190 is the temperature, minus 190. Well, where's that in this scale here? Well, 190 would be, it's between these two values here, so it would be around about here. Therefore, my oxygen is going to be in liquid form. Okay, I'm going to do the same for nitrogen. Nitrogen, there's my line. I've got minus 210, and I've got minus 195, and then I've got solid here, I've got liquid here, I've got gas here, and I'm looking for 190. Well, minus 190 is going to be about here, which means I've got gas for nitrogen. Carbon, where are my fixed points for carbon? Ooh, sublimates minus 78, interesting. So this one, so carbon dioxide is an odd one. It's got minus 78 degrees Celsius, and what we've got here is we've got solid, and there's no liquid carbon dioxide, so it's solid or it's gas. Okay, so it's, and where's minus 190? Well, that's definitely over down here somewhere, isn't it? So it's definitely a solid. Carbon dioxide is a solid at that temperature. Okay, that's how I'd always approach those questions. I think about that line and I put in the fixed points for that substance in those questions. Right, let's have a look at question D, part D. So the air also contains a small amount of argon. As the temperature of the air decreased from 20 degrees Celsius to minus 190, the argon changed from a gas to a liquid to a solid. Okay, so explain the changes in the arrangement and movement of the particles of the argon as the temperature of the air decreased. Okay, so argon goes from solid to liquid to gas. It's worth 6 marks. 1, 2, 3, 4, 5, 6. Explain is a describer plus. So describe what happens, say why it happens. Well, what have we got? It starts off at solid, so it goes, I'm going to describe it goes from solid to a liquid. First of all, I'm going to say what happens to the particles, the arrangement of the particles, and then I need to say why. Okay, so as argon cools, sorry, I've said solid to liquid is the other way around, isn't it? It goes from gas to liquid because it's cooling down. As argon cools, the particles slow down. Or as argon gas, sorry, cools, particles slow down, get closer, and it condenses, I'm trying using keywords when I can, condenses into liquid. Okay, so I need to say what's going on there, or why the particles getting closer. So I might even draw a couple of little diagrams here just to show particles far apart, getting closer then. Okay, so I've got 5 particles. Okay, I've got 5 particles gas, just so I know roughly what's going on. I don't really like no, I look at my liquid there. Let's put liquid. Oh no, it looks even more like a solid. Okay, so there are my notes there, just to show hopefully show what's going on. Why is it going on? Well, the internal energy of argon decreases. As it cools. And what we're getting there is we're getting attractive forces between particles starts to increase. Or dominates. In fact, pulls them together. Okay, so that's why the particles get closer. Okay, then what happens? So if started off with I've got gas to solid, gas to liquid. Then I've got as liquid argon cools, its particles slow even more. Okay, what else happens? Particles get closer and they move into a regular shape. So move into fixed positions, fixed regular pattern. Okay, so why is that going on? In fact, regular pattern of a solid. Okay, so I'm going to move my bullet point there a little bit. Okay, so why is that happening? Well, as internal energy decreases even more, attractive forces are even stronger. In a solid. Okay. I've got 1, 2, 3, 4 bullets. I've probably got 2 more bullets left to write about. So let's try and think what else I can write about that. The density's changed, hasn't it? So the particles are closer. I've probably done enough to get the 6 marks already, to be honest, because I've made lots of links there. But let's make sure. So since particles are closer, the argon is more dense. Okay, and what else can I say about? I can also say I know that internal energy equals the kinetic energy of particles plus their potential energy. Okay, so I've managed to write an awful lot in there for that question. Okay, but it's a 6-mark question. Really what it's talking about is describe what happens to the particles when you go from a gas to a solid, isn't it? Okay, it might well be that I might have used headings. In the real exam you'd have more space than this, remember, as well. I've condensed mine down. I would probably have put a diagram in there, even if I drew it underneath, just to really show, because my first diagram was dreadful. just to show that I knew what was going on, I'll put these little lines to show that these things are moving around very quick in random directions. So that's six particles goes to 6 particles, making sure that it's kind of random. At least some of them are, touching, and then finally we end up with fixed pattern like that. Okay, so that again would help describe what's going on in terms of, if the examiner saw that, although I've done these big circles over here, oh dear, that's a quick sketch. I'd probably take a little bit more time making sure my particles are all the same size as well. Okay, I hope that helps. Take care.